So this is another question from IIT JEE PYQ. The question is from the year Advanced 2011. Okay, and the question is based on the concept of circular motion here. And the question is, a ball of mass m 0.5 kg is attached to the end of a string having length 0.5 meter. So here L is given as 0.5 meter and mass is given 0.5 kg. The ball is rotated on a horizontal circular path about vertical axis. Okay, so here this ball is rotating in the horizontal circular path like this. Okay, and the maximum tension in the string that can bear is T max, that string can bear is 324 Newton. The maximum value of angular velocity of the ball is what? That we have to tell. Okay, so here I will draw the situation for this conical pendulum. This is the case of conical pendulum actually, and this is our pendulum here. This is the vertical axis. This is the length L, and this ball is rotating in this circular path. Okay, now to solve the questions related to the circular motion, what we have to do, we have to write the equation of motions in the plane of this circular motion and perpendicular to the plane. So here I will write the force is acting on this body mass m. One will be the tension force in this direction, and if I assume this angle is theta, and there will be a downward force mg, that is the weight of this body m, then component of this tension force along this direction, that vertical direction, that will be T cos theta. Okay, so here if I will write the equation of motion in the vertical direction, then T cos theta will be balancing. T cos theta will be balancing that weight of this body. So let me assume this is the equation number 1 here. Okay, now let me assume that this body is rotating in a circle, doing circular motion in a radius that is equal to r. R is the radius of this circular path here. So what is the force? What is the force that is providing it necessary centripetal acceleration so that it is able to move in this circular path? Let me call it is moving with an angular speed omega. Okay, so here the component of tension force in this direction, that will be T sin theta. So here T sin theta is providing the necessary tangential acceleration for this body, that so that it is able to move in this circular path. So T sin theta will be equal to m omega square r. Okay, and from this triangle if I write what is the value of sin theta, so let me call it equation number 2 by the way, and I will write this equation number 2 here. T sin theta will be equal to m omega square r. Okay, so in this triangle, like this is our triangle, I will draw here. This is the angle theta, this is the length L, and this is the radius r. If I write the value of sin theta, then sin theta will be equal to what? It will be equal to r by L. So if I substitute the value of this sin theta, then T dot r by L, that will be equal to m omega square r. So here r will be cancelled out on both sides. The value of tension in the string will be equal to m omega square L. Okay, so this is the general case for this conical pendulum. At every point, in any situation, whatever the angle theta is, the tension in the string will be equal to m omega square L. L is the length of string here. Okay, so here the value of tension in the string is given, that T max, that is equal to 324 Newton. Okay, that will be equal to mass into omega square into L. Okay, so the value of omega square will be equal to what? 324 divided by m into L, and the value of mass and length is given as 0.5 kg and 0.5 meter. So let me substitute all these values. 324 by 0.5 into 0.5, that will be equal to 324 into 100 divided by 25. So this will be equal to 4. So the value of omega we will be getting here under root 324 multiply 4. That means 18 multiply 2. That is equal to 36 radian per second. Okay, so the maximum value of that omega angular frequency we are getting here 36 radian per second. Okay, so whatever the angle theta is here, for the maximum value of tension we are getting this omega angular velocity. The maximum value of angular velocity is 36 radian per second. Now if we want to calculate the value of this angle theta, then we can divide these two equations, equation 1 and equation 2. Then equation 1 and 2, let me write here. If I divide equation 1 and 2, then what I will be getting here, t cos theta by t sin theta, t cos theta divided by t sin theta, that will be what? T cos theta is equal to mg divided by m omega square r. So mg divided by m omega square r. Okay, so here m will be cancelled out and tension will also be cancelled out. So here cos theta divided by sin theta, that will be equal to g by omega square dot r. Now again if I write the value of sin theta in this equation, that is equal to r by l. So here sin theta is equal to r by l. So this cos theta divided by r by l will be equal to g divided by omega r. Okay, sorry, it was here omega square, so here will be omega square r. Okay, so on both sides r will be cancelled out and cos theta value will be equal to what? G by omega square l. Okay, so this is the general formula for this conical pendulum. We can use in any situation that what is the value of theta here by putting these values omega and all. Okay, so this is the general case for conical pendulum, and our answer for this question is what? Omega will be equal to 36 radian per second. Right? Thank you.